So first I go to Wokwi. I select the board here. Wokwi is a very nice software for simulate different types of hardware. So I'm selecting a new project. Scrolling down, we will use an Arduino Uno for this test. So now we have our board, and for this we will use the blinking LED on the board. That's the first test. So I'm starting up the Visuino. So then we have our Arduino Uno. And first we will add a pulse generator. So we search for that in the components window. I will move it down because I want to use the digital output 13, which is connected to the LED on the board. So that's it. The frequency of this is 1 second. Then we go to build. I select the board I have. Then I compile and build. Then we have we can copy the link to the hex file, the generated hex file. And here we can press F1. We click the first in the programming window and select F1, search for the firmware and upload firmware and run. I paste in the link, and as we can see we have the LED blinking on our virtual board. So this is very nice. So this first test is working. So let's try to stop the project. We're adding a new part, and we have many parts we can select from. The basic one is a LED. We'll select one LED, and then a resistor for that LED, and a push button. So now I will place them around. This looks fine for me. Then we're connecting some wires. Make sure you click when you want them to like bend. And we can speed up the clicking here. We're adding all the connections. This connection will with the button will connect the pin number 2 to ground. This will be an input pin. So back in Visuino we need to make that that connection. We first select the board, and for this type I will use a method that I find the best. So for the digital 2, that was our input, we will set that as a pull-up. Then it's a small resistor will be added to our board inside the microcontroller that will hold this input high all the time. And it's safe to short that input pin number 2 and will then set the state to low. So in real projects, the buttons, when you click the button, it can be small sparks when you click it, so that the input can go high and low very fast. So we will use a debounce button, and that will ensure that it has to be some time, like 50 milliseconds, to ensure that it's only clicked once. Some switches, when they're becoming a little bit bad, when you toggle, you can get 2 and 3 clicks in each press. So we see that it goes to pin number 2. Back in Visuino, the signal coming in will come out from number 2 in the Visuino program. We take it into the button. Yeah, we can check this debounce and 50 milliseconds. That means that it will not trigger again until 50 milliseconds has passed. That will ensure that we have no bad connection or spark or anything when we push the buttons. Then we will look up for a toggle, a flip-flop toggle. We connect from the debounce button out. Checking the 2 again. Yeah. On the button. So that's my mistake here. It should not go to toggle. This is actually if you want to enable or disable the flip-flop. I will remove it. That's very nice with the Visuino also, that you can just click and delete, and if you have done this mistake in a code or something, it's much harder to fix. Every time there comes in a clock here, we will toggle this at the output, and the inverter will toggle the state. And we connect the output into the digital 9. So that will set the output on the board. Input in the Visuino will be the output on the board. Seems like our code is complete now. We have forgotten that when we using the pull-up resistor, we can check here again. When we're pulling that one up, then it will be held high when the toggle button, the button is not pressed. So here we need to invert that signal, since I did it this way. But I save one resistor in the connection. I disconnect the wire, and I take the digital 2 into the inverter. That means when it's always high there, which will be in a normal condition, it will be always off when the button is not pressed. So I save one resistor in the connection schematics by doing like this. It's my favorite method of doing it. Then I compile and upload, build or upload. We will not upload in this, it will just fail there. The only thing we want is the hex file. So I copy that again, pressing the F1, clicking first on the programming window and clicking F1, selecting upload from firmware and run the program, pasting in the link. And now we can see the LED on the board is blinking with 1 second. And our button is also working to turn the LED on and off. It's a very nice way to test new sensors and testing new boards and all this. So thank you for watching.